Hey there, ladies and gentlemen, boys and girls. Today I'm going to show you guys how to distinguish between the five types of chemical reactions. So we learned about how to balance reactions. Now we can actually classify them into five major categories of chemical reactions. And you can see it here: synthesis, decomposition, single replacement, double replacement, and combustion. All right, and then what we're going to do is we're going to practice by looking at a couple of an example of each. All right, so have your handy dandy notebook out. There's going to be times where I'm going to pause so you can write all this stuff down, and we're going to talk about it going forward. So let's start with over here on the different types of chemical reactions. All right, so we have the five different types here. You can go ahead and read a little space here. All right, the way that we normally write this is kind of almost like an equation. All right, where we use different variables like you would in math class to have x represent different numbers. We use kind of a general equation, but we use letters to represent, generic letters to represent different elements. Like A could be any metal, or B could be, so, and I'll show you what I mean as we go through this. All right, and it really follows kind of the same pattern. I'm going to be using a lot of colors here because that really helps us distinguish it, especially when we get the double replacement. All right, so I would recommend having at least 4 different colors as well. You need to go grab that pause real quick. All right, let's go do this. All right, so first one is a synthesis reaction where we're going to create something. All right, and so the way that we kind of notate this kind of equation to do this, to represent and identify it, is we have element A. Now that element A could be any element, but notice it is by itself. It is not bonded. It does not have that relationship. It is not ionically or covalent bonded. It's all by itself. It could be a zinc. It could be an iron. It could be an oxygen. It's an element by itself plus another element that's by itself. All right, and that is going to create a relationship between those two, that they are bonded together. Now there might be subscripts. It's not showing those subscripts. You have to include that, but it's just basically saying I have 2 individual elements to combine to make one molecule or a compound. You just have to kind of apply it depending whether this is a calcium or a magnesium, or whether this is an oxygen or bromine, whatever it is. You just combine these 2 together. This is called a synthesis reaction. All right, the opposite of this is if we take any element or compound where 2 different elements, A representing one element, B representing any other element, and it is broken down into those 2 separate elements. So then we have the A and B. All right, so these kind of opposite of each other. Synthesis means to create something, decomposition to break it down. All right, so now let's get a little bit trickier. This is what's called single replacement. All right, this one can be written in a couple ways, but I'm going to do kind of the generic here. All right, where we have, say, an element by itself, like A, and it's met with an element that is already bonded. So like B and C are bonded together. They are already in a relationship. So we have one that's just an element, and then we have one that's a compound. And then in the reaction, it is a single replacement. We are going to swap the bonds. So in this case here, it could be, let's just do in this example, it would be an AB, all my colors here. And now C is by itself. Now this would also work if it was like, A plus BC yields AC plus B. That's fine. The idea is that one of these in the compound switches over to the one that's not with it. So this could also be AB plus C, and as long as one of them switches. All right. A double is kind of the same idea, except for 2 of them switch. This is almost like swapping on a double date. All right, so let's say we have element A and B. With elements, another molecule, C, say element is bonded to element D. In this type of reaction, they are going to kind of flip partners. Which one, which, doesn't really matter. All it is that we flip-flop it. So then now let's say A is with C. Right? And B is with D. Right? It doesn't really matter which one it is in the fact of does it become AD and BC? It doesn't matter. It's just that the idea that two elements kind of switched who they were in a bond with. All right. Now this last one is actually kind of the easiest one to identify, but it's much different looking than the other ones. This last one's called combustion reaction. All right, and it's a little bit different how it looks, and so it's easy to identify. All right, it's any kind of carbon. So it's literally C for carbon. Doesn't matter which number's there. And a hydrogen, which it doesn't matter what subscript it is. It could be a 5, this could be a 10, this could be a 50, this could be a 7. It doesn't matter. When it goes with oxygen, and it's always oxygen. If you see oxygen in its reactants, that's a good sign that we have a combustion reaction. And it always gives the products of carbon dioxide and water. So the carbon dioxide and the water always are the products. Right? Really all that's changing is this is called a hydrocarbon. Right? What goes here, and then we'd have to balance the equation. All right, so that's our 5 different types of equations here. All right, let's take a moment and let's practice identifying the elements or the different types of equations. So I have 5 equations there. I'm going to kind of model how I would work through this. I like to give each element kind of the letters A, B, C, or D. All right, so let's kind of go through this one here. It doesn't matter which one you give. It just kind of however you want to do it. So I'm going to say, I have aluminum oxide breaks down to aluminum and oxygen. I'm going to say that's letter or oxygen or aluminum's A. Oxygen I'll make B. And in this one here, I end up with A and B. So they're together, and then they're separated, together, and then separated. This is a decomposition. All right? Let's try another one. So let's see here. All right, ooh. Oxygens in the reactants doesn't automatically mean it's or what I think it's going to be, but I also see carbon dioxide and water as the products. That's a dead giveaway, right? Where we have a combustion reaction. I don't even need to use letters. I have a combustion reaction. All right, let's do this third one. I'm going to say all the sodiums in this one are A. We'll do all the chlorines as B. And all the fluorines as C. All right, so I have A and B together, C by itself, and now A and C are together, and B is by itself. That kind of looks like this one right here. That is a single replacement reaction. Single replacement reaction. All right. Now let's try the next one. I'm going to make lithium, all the lithiums A's. I'm going to make all the bromines B's. So we start A and B separate and then together. Separate and then together. This is a synthesis reaction. All right. And let's do our last one here. Ooh, this one looks kind of complicated. Let's put all our letters. I'm going to make copper A. Remember, the A, B, C, D, they don't mean anything. They just help us identify and simplify the equation. I'm going to make all the coppers A, all the chlorines B. Next, I'm getting hydrogen. I'll make that C. And then I'll make, I have a fourth one. I'm going to make sulfur D. All right, so I have A and B plus C and D makes AD plus CB. A and B plus C and D, where we have flip-flopping. Both of them flip-flop. A and B are no longer together. C and D are no longer together. That is the sign of a double replacement. A double replacement reaction. All right, so that's how we basically identify the different types of chemical reactions, different types of reactions. So here are our 5 reactions. All right. I like using the letters just to randomly assigning it to them to help them kind of think about which one's which. All right. This is pretty straightforward. Some of them are a little bit harder to see. Some are pretty easy. I think synthesis and decomposition are pretty easy. Composition combustion, as long as you take your time and see those products. If you see that product, it's a dead giveaway. These two can be a little tricky, telling the difference between them, but more practice helps you with that. All right, so that's going to be it for this video here on the different types of chemical reactions. Now go out and practice. All right, see you later. Good luck, and may the science be with you.